So trig identities or trigonometric complex identities. Usually problems involving trig identities fall into two types for complex numbers. The first type is expressing cos n theta and sine n theta in terms of powers of cos theta and sine theta. So look, see how that's a multiple theta. So that's the way you're probably going to hear me say it more often. Multiple. Do we understand why it's multiple theta? Because it's multiplying the theta, multiple thetas. Whereas this is powers of theta. And of course, again, you can see why. Because it's to the power of 4, power of 2. Right? So the first type is multiple theta in terms of multiple theta equals powers of theta. The other one is powers of theta in terms of multiple angles. Multiple angles. In fact, that should have been cos. Do we get that? Do we see the difference firstly? Right, type 1, multiple angles in terms of powers. Type 2, powers in terms of multiples. Yes, we realize there's a difference?
Yep.
Cool. The easier one is type 1. The harder one is type 2. In an exam, in a HSC, it's usually one or the other. It's very rarely both. So you need to know both, but in your exam, unfortunately, you won't know which one you're going to get for this topic. You just have to know both. All right, let's start with the first one anyways.
Sir, so it's the difference between the two is just whether which one is the subject?
Yeah, that's what you've got to realize. So if your multiple angles the subject, then it's a type 1. If it's a power that's a subject, then it's type 2. Correct. All right. So how do we do these ones? These ones are the good ones. All right, step 1. Let z equal to cos theta plus I sine theta. You gotta first let z equal to cos theta plus I sine theta. Now, what do you think the power would have been? What do you think the power would have been for me to get this? What do you think the power would have been for me to get an answer like this on the left-hand side? Take a guess. What are we thinking the power would have been? What number comes to mind?
4?
Yes. So that's how you have to look at it. So the only way you're going to get your answer is by looking at this solution here and realizing, okay, the fact that it's 4 theta, maybe what's happened is if I've let z equal to this, using de Morey, if I take this to the power of 4, I can actually end up with this response. So now we're going to go using de Morey's. You have to actually write that. Using de Morey's theorem, cos theta plus I sine theta to the power of 4 equals cos to the 4 theta plus I sine to the 4 theta. Any questions there, Julia?
Yeah, wait, so why do you make it a power?
Why did I make it a power? I mean, that is what we're meant to do. I can't really do anything else about that. Yeah, that one you got to accept. But you're about to see why it's going to work in a second.
Okay.
So using de Morey's theorem, we got multiple angles. Again, you can see that. We got multiples now, but I'm still missing my actual powers of 4 and power of 2 and all that, right? using binomial expansion. So now, using a binomial expansion, we're actually going to expand this thing. Now, I know Queenie knows how to do it. Caleb, I think you know how to do it as well, right? Do you know how to expand these using binomial expansions?
I forgot how to.
Forgot? All right, then we'll revisit it for everybody. Then let's do it. So using binomial expansion. So what we're going to learn now, you guys, is actually how to expand this power of 4. The first thing you need to learn to do, it is Pascal's triangle, but I'll let your teachers cover that in school. The first thing you want to learn to do is we've got to find the coefficients of these. So let's say if it was power of 4, the way we're going to find our coefficients is actually quite simple. You want to do 4 and then the choose button on your calculator. So that's shift divide and then 0. Press equals, we should get 1. Is that correct?
Yeah.
Or choose 1.
Yeah.
You keep going all the way up to 4. So you're about to, this is working out all of your coefficients. So 1, 4, 6. And then because it's symmetric, you'll realize, because of Pascal's triangle, but like I said, I'll let your teacher deal with that. I don't want to bore you with that stuff. 1, 4, 6, 4, 1. That's our coefficients. Easy to do. Obviously, this number changes according to your expansion. So if it was a power of 3, that would have been 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. Rav, what's our coefficients of a perfect square? Generally, like if we're a basic one like this, what's the coefficients?
1.
1 and then?
A squared.
Well, technically, yeah. Yeah, that's fine. I was just looking at the numbers. I'm not looking at a squared. So 1 and then 2
2.
and then 1, right?
1. Yep.
And then now check it out. 2 choose 0, 2 choose 1, 2 choose 2. So that's all you're doing. You're just trying to work out those coefficients. Confirm? You agree, Rav?
Yep.
Yeah. So that's what we're doing here as well. We're just trying to find the coefficients. Once we have that, it's actually quite easy to expand this, as long as you follow this rule. Rav, you're about to tell me the answers. Here you said a squared, then what is it? AB.
Yep.
Then?
B squared.
B squared. Now, if you realize, there's actually a pattern here. What's happening is the first one was squared, then we decreased that by 1, and we increased the other one up by 1. So look at it, a squared, decrease it by 1, so that becomes a to the power of 1, but then the other one, we have to increase it by 1, so b. Decrease it a again by 1, it disappears, increase b by 1, b squared. So let's try that before I do this one here. Let's do a plus b to the power of 4. Who wants to try this? No? All right, I'll do it. Coefficient is 1, which usually you would ignore, times, what's going to be my first term? A to the 4 plus 4, then decrease the a by 1, increase the other one, plus 6, decrease, increase, plus, decrease, increase, plus. And then if you've done it right, you should always end up with something like that. Julia, what do you think? A4, A3, A2, A, and then disappears. B, B squared, B cubed, B to the 4. 4, 3, 2, 1, no more A's. no b's, 1b, 2b, 3b, 4b.
Why do you times it by 1 at the start?
Well, because that's my coefficients. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1.
Oh, okay.
1, 2, 1. You've always done it, you just never realized you were doing it.
Ah.
So try one more. Maybe I should have done that as our first exercise before jumping into trig. I forgot. A plus b to the power of 5. Go. Let's work out our coefficients first. Julia, you're going to do this one with me.
Oh,
So just let me know when you're ready.
I will try.
Okay. Here we go. Well, your coefficient's always going to be 1 at the beginning anyway. So what's the very first one? A to the power of?
5.
5. Then plus 5. A to the power of?
4. Wait, no, sorry. Ooh.
Has to be 4. Yep. And then you can't have, pretty much these numbers need to add up to always give you your power. Right? Because you're always decreasing one but increasing the other one. So you can't just have a to the 4. Sorry?
Oh, I just said O.
Okay, and then b to the 1. Does that make sense?
Yeah.
I decreased one of the a's, but then I increased my second letter. Go, next.
Plus 10, a to the power of 3, b to the power of 2. Plus 10, a to the power of 2, b to the power of 3. Plus 5, a to the power 1, b to the power 4.
Good work. Do we need more work on that? Is that kind of making sense now?
Oh, I get it now. Yeah.
All right, rub this out. We don't need it. We'll be doing it again very soon in our 3-unit class anyways. I'll be with you guys next week. Using binomial expansions. All right, so now let's see if we can apply it to this one. Who wants to give it a shot? Cos theta, which is A, plus I sine theta, which is B.
I can do it.
Yeah, go ahead.
Cos theta to the power of 4 plus 4 cos to the power of 3 I sine plus 6 cos to the power of 2 I sine power to 2.
No, I squared sine squared theta. Remember, the whole thing's squared. The whole B term is squared. I think that's all right. Yep, next, continue.
Plus 4 cos theta I to the power of 3 sine to the power of 3. And then, yeah.
Wow, how good's that? Like I said, algebra. If you like algebra, this will be easy eventually for you. This is nothing. If you don't like it, if that's scary to you, then maybe not the right course. You just got to reevaluate everything soon. Cool. But I think for all of you, you love algebra, so this is easy. Okay, and then let's I guess make this one just a little bit better, right? So the next line is cos to the 4 theta plus 4 cos cubed theta I sine theta. Now, what can I simplify from my third one here? Something can happen.
I squared becomes negative.
Done. I squared is negative, so negative 6 cos squared theta sine squared theta. The reason why that's important is if I told you which ones are real, you guys might have just said, oh, just the first one. But technically, there's more. So you've got to be careful. You've got to simplify them first. So that's good. And then what about I cubed? What does I cubed become?
Negative I.
Negative I. So negative 4 cos theta. I sine cubed theta. And then again, what does I to the 4 become? That becomes 1. So that's just positive sine to the 4. Any questions there? We're very close. So let's recap what we've done. Multiples in terms of powers. We let z equal to cos theta plus I sine theta. We use De Moivre's theorem to expand. Then we stop. Then we use binomial expansion, that exact same thing you've written. You don't do it by De Moivre. You say, what if I did it by binomial? You'll expand it. You simplify it. And now, does anyone know how I'm going to link this to end up with this? Only this. Think back to week 1 if you have to. Only.
You make it equal to each other.
How? What specific? I'm looking for a word. You're not wrong. How come this disappears?
You're equating real parts.
Yeah, perfect. That's it. So nothing too crazy. All you're going to say in your next line then is equate real. Obviously that means if this was sine 4 theta, I don't think I need to tell you, you just equate imaginary. One sec, equate real, and then that's it. So cos 4 theta, right, equals the real parts, which is cos to the 4 minus 6 cos squared sine squared plus sine to the 4 theta. Now, just give me a second, guys.
Okay.
Thank
All
you.
good, Minnie?
Done.
That's it for me?
Yeah, that's it.
Okay.
All right, you guys. So, any questions just yet for where I was up to? We're good. But what's the difference, obviously, from what I'm asking you to show and what you have here so far?
The sign.
The sine. So what are we going to do? We're going to change all my sine squares to eventually cos squares, and then we should be done. So next line, cos to the 4 minus 6 cos squared. Sine squared is 1 minus cos squared. Sine to the 4, there is no such thing, so you can only do it as sine squared squared. Wait, did we get that? One more time. Sine to the 4 is sine squared, which is 1 minus cos squared, squared. Just ask me if there's any questions while I expand this. Eight cos minus 8 cos squared plus 1. Yep, done. All right. So what do we think? All good? Any questions? Rav, any questions from you?
No.
No? You feel like you might be able to execute something like this? Just a whole lot of algebra, really?
Maybe.
How do you feel about it? Does it feel daunting writing all of this trig, or do you feel comfortable writing it?
That's all right.
Okay. Find out. Let's do it. Let's go to here. And let's see. We'll stop that one.